Have you ever wondered how your favorite ice cream is mass-produced? Come with us on the journey from farm-fresh produce to delectable desserts straight from your freezer. Every scoop begins with the best ingredients: premium milk, cream, sugar, and natural flavorings. Milk and cream are frequently sourced from nearby dairy farms and must meet stringent quality standards. Farmers ensure that the dairy is fresh and nutrient-rich by maintaining a consistent fat level to achieve the creamy texture of quality ice cream. Another crucial ingredient, sugar, is rigorously refined to ensure that it dissolves easily into the mixture, adding to its sweetness and smoothness. Our natural flavor choices are guided by their origin and quality, whether they be vanilla beans, chocolate, fruit purees, or something else. Vanilla, for example, could originate in Tahiti or Madagascar, both of which are known for their distinct flavor profiles. Fruits, such as strawberries and mangoes, are sometimes purchased at their peak ripeness to enhance their natural sweetness and aroma. This commitment to excellent ingredients ensures that ice cream delivers the rich, delicious sensation that customers desire. Many ice cream factories engage directly with surrounding farms to obtain milk and cream, ensuring maximum freshness. This strategy ensures that the dairy is delivered to the factory within hours of collection and encourages ecologically friendly farming practices. Sourcing flavors, such as chocolate and vanilla, are also rigorous. While vanilla beans are hand-picked from regions such as Madagascar and are known for their strong aromatic properties, cocoa is typically obtained through fair trade programs, which ensures ethical farming and high-quality beans. These quality components serve as a foundation for the rich, creamy taste that consumers adore. These components create the basis of the ice cream by being blended into a smooth mixture. Milk and cream are measured and poured into large stainless steel mixing tanks where sugar and stabilizers are added. Stabilizers such as guar gum and carrageenan aid in keeping the creamy texture by preventing the formation of large ice crystals during freezing. Careful monitoring of the blending process ensures that the mixture is homogeneous, with no clumps or unequal ingredient distribution. To kill any harmful bacteria, the mixture is pasteurized for a few minutes at temperatures ranging from 80 degrees Celsius to 85 degrees Celsius, 176 degrees Fahrenheit to 185 degrees Fahrenheit. This procedure ensures food safety while also improving the taste and consistency of the final product. Following pasteurization, the mixture is rapidly refrigerated to around 5 degrees Celsius, 41 degrees Fahrenheit, to prevent spoilage and prepare it for the following stages of manufacture. Once blended, the mixture is subjected to preliminary testing to confirm that the balance of sweetness, fat content, and flavor meets the manufacturing specifications. At this point, personnel collect samples to assess homogeneity of the mixture and, if required, make changes. Each batch is uniform thanks to the specialist sensors in the mixing tanks that constantly monitor viscosity and temperature. This level of accuracy not only ensures quality, but also prepares the mixture for the critical homogenization and pasteurization steps. The mix then homogenizes to produce a uniform texture and creamy consistency. Homogenization involves passing the mixture under high pressure via a series of small valves. By breaking down fat globules into small, uniform particles, this process ensures that they are evenly distributed throughout the mixture. The end result is a smoother, creamier texture that prevents the mixture from splitting during freezing and storage. The homogenized mix also improves the mouthfeel of the finished ice cream, resulting in a rich, velvety texture that melts evenly on the palate. This stage is critical for premium ice cream because it reduces graininess and unevenness. During homogenization, modern technologies monitor pressure and flow rate, to ensure consistent results between batches. Homogeneity is also a significant factor in boosting the overall stability of the ice cream. By decreasing fat globules to tiny proportions, the components, fat and water, are perfectly emulsified, avoiding any separation during freezing or storage. This method is essential for producing the rich, creamy texture that consumers expect from luxury ice cream. Advanced homogenization technology allows for precise pressure control, ensuring that even the smallest batches meet the same high requirements as larger ones. Then aged to improve its texture and flavor is the homogenized mix. The mixture is aged in insulated tanks at around 4 degrees Celsius (39 degrees Fahrenheit) for 4 to 8 hours. This cooling time allows the proteins to completely hydrate while the fat globules partially harden, resulting in a more stable, creamy texture. The aging process also increases the mix's ability to accept air after freezing, which is necessary for achieving the desired lightness in the finished product. The blend is carefully stirred during the aging process to maintain homogeneity and prevent any ingredients from settling. Technicians closely monitor the temperature and viscosity to ensure that the mix has the proper consistency for the next steps. Premium ice cream is heavily reliant on this stage, since it provides the foundation for its creamy and velvety texture. Natural flavors in the mix begin to develop and mature during the aging process, resulting in a more well-rounded taste profile. Gentle agitators incorporated into the cooling tanks keep the mix in constant motion, preventing settling and ingredient separation. This stage also allows emulsifiers and stabilizers to activate fully, increasing the mix's ability to maintain a creamy texture even after freezing and storage. By the end of the maturing phase, the mixture has achieved the ideal consistency and taste to prepare for the next steps. After aging, particular flavors and colors are introduced to create a variety of ice cream options. Fresh fruit purees, rich chocolate syrups, and vanilla extracts are added to the aged mixture and poured into large flavoring vats. Careful mixturing of these tastes ensures consistency between batches. Natural colorants such as turmeric for yellow tones and beetroot juice for red hues are used to create visually appealing ice cream while maintaining a clean label. Flavor mixing is a sophisticated method that requires continual swirling to distribute the ingredients evenly. Advanced mixing processes ensure that each scoop tastes and looks identical, eliminating the formation of air pockets or streaks. Before freezing, quality control teams sample each batch to confirm flavor intensity, sweetener levels, and color brightness. Adding flavors and colors is a refined creative endeavor. To ensure depth and richness for popular flavors such as chocolate or vanilla, the taste concentrates are combined in stages. Fruit-based flavors are handled with precision. Fresh or frozen fruit purees are gently warmed before being blended to enhance their natural sweetness and aroma. Natural colorings, such as spirulina for greens and carrot extract for orange tones, are also employed in factories to ensure that the end product is visually appealing while being free of synthetic ingredients. It is then fast frozen while air is incorporated to achieve the perfect creamy texture. The mixture is churned and quickly cooled to around -5 degrees Celsius (23 degrees Fahrenheit) before entering continuous freezers. This controlled freezing process creates small ice crystals, which gives the ice cream its smooth texture. Air is simultaneously swirled into the mixture, a process known as overflow. This stage determines the density of the ice cream. Base versions have more air for a lighter texture, whereas luxury ice creams have less overrun, resulting in a richer, denser product. Freezing operation is precisely timed to give the ideal balance of creaminess and firmness. Automated procedures ensure consistent outcomes between batches by monitoring air inclusion levels and temperatures. By the end of this stage, the mixture resembles soft-served ice cream and is ready for direct packaging or mix-ins. Air or overflow is a highly controlled process that directly affects the density and texture of the ice cream. While more competitively priced creams can have up to 50% overflow for a lighter texture, high-end brands often limit access to 20 to 30%, resulting in a more prosperous, creamier product. Apart from supplying air, the churning movement during freezing ensures that the mix remains free of large ice crystals, keeping its smoothness. By the end of this stage, the ice cream has reached its characteristic creamy consistency and is ready for any additional ingredients or packaging. Delicious mix-ins are added to the ice cream to create unique flavors and textures. Once the ice cream has reached the desired semi-frozen consistency, they carefully fold in mix-ins such as chocolate chips, caramel swirls, cookie dough bits, or fruit pieces. Specialized instruments ensure that these contaminants are melted or broken free throughout the batch. Every mix-in is added at specific temperatures and speeds to preserve its integrity and form, ensuring a balanced taste and texture with each scoop. For flavors with swirls or layers, such as caramel swirl or fudge ripple, the inclusions are injected into the ice cream as it moves along the conveyor, creating an aesthetically attractive pattern. Quality control tests ensure that each batch meets product specifications, that mix-ins are distributed fairly, making each mouthful a pleasant experience. This stage adds excitement and variety to the ice cream. Mix-ins are added with incredible precision to ensure that every scoop has texture and flavor explosion power. Cookie pieces, nuts, and candies are refrigerated before being added to semi-frozen ice cream to prevent them from melting or becoming mushy. For ripple-style inclusions, such as caramel or fudge swirls, specialized nozzles inject the sauces in an artistically attractive pattern. Every batch is consistently monitored to ensure an equitable distribution. Visual inspections and sensors ensure that mix-ins are consistent across the whole product range. The final step is packaging and hardening, where the ice cream is made ready for distribution. Automated filling machines facilitate the distribution of semi-frozen ice cream into containers. These gadgets ensure precise portioning, filling each tub or carton with just the right amount. Once loaded, the container's airtight lids maintain freshness and prevent contamination. Some high-end items may incorporate tamper-evident seals for added security. Following sealing, the containers pass through a hardening tunnel where temperatures drop to around -30 degrees Celsius, -22 degrees Fahrenheit. This rapid freezing solidifies the ice cream to its desired consistency and prevents large ice crystals from forming. Once hardened, the goods are marked and organized in storage facilities, ready for shipment to retailers and, finally, to your freezer. Teams in quality control conduct final checks to ensure that every container meets the company's high requirements. The packaging materials are specifically made to act as a barrier against light and air, so preserving the flavor and texture of the ice cream and maintaining the best standards of freshness. Some upscale manufacturers use double-layer packaging to ensure the ice cream arrives in perfect condition. Containers are gently spun throughout the hardening process to promote consistent freezing and so aid in eliminating temperature variations. Before shipment, packaging is checked for proper sealing, and any strange containers are removed to ensure that only the best goods reach the store. Every batch passes through quality checks to guarantee it satisfies the highest criteria before leaving the manufacturer. Quality control teams use taste, texture, and consistency inspections, among other tests, to ensure that the finished product meets the brand's promise. Every batch is further tested for microbiological safety, ensuring that the ice cream is free of contaminants. Automated scanners check for the correct labels, seals, and fill levels, ensuring packaging accuracy. Any tubs that do not meet the criteria are identified and removed from shipment. Once permitted, the ice cream is loaded into temperature-controlled trucks to ensure that it remains at the ideal freezing point throughout the journey. GPS tracking technologies included in these trucks provide real-time temperature and position monitoring. The ice cream is transported from the plant to homes, restaurants, and stores all across the area, allowing consumers to enjoy this delectable treat wherever they are. Random samples from each batch are set aside for further testing in on-site labs to ensure uniformity. These tests evaluate not only the flavor and texture of the packaging, but also its structural integrity under various conditions, including vibrations during shipping. Visual assessments of premium lines focus on features such as swirl patterns, mix and distribution, and color balance. The cold chain logistics are meticulously maintained, with constant temperature data kept to ensure that the ice cream arrives in the exact condition in which they left the factory. Every stage in making ice cream is a mix of precision, passion, and a little magic. From fresh ingredients to the ideal scoop, consider the journey your favorite ice cream flavor took, from the producer to your freezer the next time you indulge. It is a masterpiece of craftsmanship and attention, designed to make every bite a joy rather than a treat. We appreciate you visiting behind the scenes to see how ice cream is made. Remember to like, subscribe, and click the bell for more delectable food analysis. Stay calm and enjoy the deliciousness until next time.